Okay, so what is a stem and leaf plot? Stem and leaf plot is going to be a quick way to organize large amounts of data. So here's how you do it. One, you start with find the largest and smallest number, then identify the biggest place value. Okay, place value is the second digit, or it's the front digit rather. Draw a vertical line and list the stems, the biggest place value on the left, and then fill in the leaves with the corresponding stem, then arrange in order from lowest to highest, and then create a key. So if you see this set of data down here at the bottom, we can start to kind of build what this is going to look like. So you see you've got the number 100 is definitely the highest, and then the lowest on here is probably going to be 63, I believe. So that's the lowest, that's the highest. So your stem and leaf is going to look like this. You're going to go 6, 7, 8, 9, 10. Those are going to be your stems. And then the leaves just look like the ones digit, and you're just going to go in order from lowest to highest. So like for 60, for the 60s, I've got 63 as my lowest, then 65, then a 67, and I think that's it. But then you keep going through all the 7s, all the 8s, all the 9s, finally ending with 100. So if you take a look at what's up there, if you take a look at weekly babysitting earnings, these would be all the sets of data that you would have. So anywhere ranging from 52 to looks like 21 might be my lowest. So my 21 is my lowest. Looks like 65 is my highest. All right, so that's where my stems have to go. So I'm going to start with 2, 3, 4, 5, and 6. So 2s, I got 21, that's my lowest, but I've got 2 21s. It's not a bad idea to kind of cross them off as you go. So then I've got a 22, 23, 24, and that's all the farther I get on the 2s. Then I jump to 3s. 3s, it looks like I've only got 1 3, and that's a 37. That's all the farther I go on that. So then jump to 4s. 4s, I've got, let's see, it looks like my lowest is a 44. Then I've got 47, 49, 49. And since the 9s aren't letting me grab them, I'm just going to write in 9, 9. So 47, so 44, 47, 49, 49. So then I jump into 50s. So I got 51, 52, 53, 61. So 51, 52, 53, and then 61. Nope, that's 60. 61. So that's what my stem and leaf plot should look like. So let's see how I did. So did we match up? We match up pretty well. We made a key. So in our case, if I want to make a key, 37 means it's 37. So that's kind of what it should look like. So here's your stem and leaf plot. So now we're kind of looking at it and trying to interpret data from this. So what was the highest fee earned? 65. Oh, did we miss 65? Let's go back and take a look. Where was 65? Oh yeah, I did miss 65. I had a circle, but I didn't cross it off. So we were just a little bit off. So 65, and we're good. So it's 37 is our key, 61, 65. So let's take a look. The highest fee earned was 65. The lowest fee earned was 21. How many times happened? This says 13, but I think that's incorrect. So if you do a quick count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Or the babysitting fees earned, I think that correct answer should be 15. So what is the difference between the lowest fee and the highest fee? That should be $44. So a box and whisker plot is another way to quickly gather and interpret information from a set of data. So this is where stem and leaf plots are nice because you can build box and whisker plots from them pretty easily. So lower extreme is just lowest value. Upper extreme is just going to be the highest. Median, that is your middle score when in order. So that is your middle when you're in order. Now lower quartile and upper quartile can be a little confusing, but here's kind of the way you want to think about it. Lower quartile is the median of the lower half. So if they're in order from lowest to highest, the lower quartile is going to be the median of the lower half. The upper quartile is going to be the median of the upper half. So then your interquartile range is just going to be this, your Q1 subtracted from Q3. So that is what your interquartile range is going to look like. So if we take a look at this. So you've got 13 fish on Lake Minnetonka on August 15th. Create a box and whisker plot from this. Okay, so if we take a look, let's reorder this from small to big. So it goes 5, 6, 8, 9, 9, 12, 12, 12, 13, 14, 14, 16, 20. So right now that's lowest to highest. So now figuring out the lower extreme is pretty easy. That's 5. Figuring out the upper extreme is pretty easy. That's 20. Figuring out the median, you got to count in and look where this middle number is. So 1, 2, 3, 4, 5, 6, 7. There's my median. So my median is going to be 12. So now my lower quartile means I only take the median of this lower half right here. So my median, 1, 1, 2, 2, 3, 3. Now when there's nothing in the middle like that, I take those two numbers and divide it by 2, okay? So I'm going to take 8 plus 9 and divide it by 2. So when I do that, I get 8.5. Now I do the same thing on the upper half. So this is going to be your upper quartile. So 12, 1, 20, 13, 16, 14, 14. So I'm going to add those two divided by 2. And that's just going to give me 14. Now your interquartile range is just going to be 14 minus 8.5. So that's going to be your answer. 5.5 is going to be your interquartile range. So now we use this information to make our box and whisker plot. Okay, so we set up kind of a scale along the bottom. So we go 5, we go 10, we go 15, we say 20, and that's all the farther we need to go. So the lower and the upper, you put whiskers or you put stars. Your lower quartile, upper quartile, and median, you put bars there. So for median is a 12, lower quartile 8.5, upper quartile 14. There's your box and whisker plot for that set of data. So kind of remember how this goes. This is broken up so that 1/4 of the data is here, 1/4 of the data is here, 1/4 of the data is here, 1/4 of the data is here. So if you take a look, this is kind of the way it's set up. Lower extreme is here, median in the middle, upper extreme here, quartile 1. Oh, did I mean to do that? Quartile 1 here, quartile 3 here. All right, the quartiles make up the boxes, the extreme make up your whiskers. So mean, median, and mode, those are all things that should come into play. So let's take a look. The mean is a quantity that obtained by adding several quantities together and dividing the sum by the number of quantities. That's your mean. Mode is the most popular answer, the one that shows up the most. You can have more than one mode, and you can also have no mode. If there's nothing that shows up a significant number of times, then there is no mode. So a graph using, correlation, a graphic representation using circle divided by into sectors in which the relative sizes of the sectors correspond to the relative sizes or proportions of the quantities. That's a very, very fancy way of saying I'm going to compare two sets of data and see how they relate. So that's correlation. So bar graphs are what's left. A graph using parallel bars of varying lengths. Haha, here's kind of your dead giveaway. It says bars in there, so it should tell you that you're going to use bar graphs. So correlation kind of looks like this. You're looking at two sets of data, and you're trying to figure out, do they correlate? Do they establish some sort of pattern? The reason I'm doing this is because if I can establish some sort of pattern through here, then I can make a prediction. All right, now the more it correlates, the easier my prediction becomes. I don't like that line. I think this one might even be a little bit better fit. So if you can figure out a way to relate, you can kind of estimate, you can kind of either extrapolate or interpolate what might happen at any given time. So that's kind of what correlation is. You're comparing two sets of data that appear to be connected somehow, and you're trying to use the data to see if you can predict with it. So reminders, next week you've got a chapter 1 test.